Hello everyone, in this video I shall discuss the Vogels approximation method of finding out initial basic feasible solution for a transportation problem. So in case of a transportation problem, the initial basic feasible solution, as I've already told you, satisfies the demand and supply constraints. So in this case I would discuss the initial basic feasible solution, but before that don't forget to like, share and subscribe for more videos. So I'll be taking up an example ABC and XYZ. So this is an example where I'll be telling you how to deal with a transportation problem, initial basic feasible solution. So initial basic feasible solution satisfies the demand and supply constraints. So we have this supply here, we have this the demand here. So this is the demand and supply, and this is a case of a balanced transportation problem. So if I check from the demand and supply side, the total on both the sides is 42. So in Vogel's approximation method, what I do is I have to calculate the penalties. So in this case, I'll calculate the penalties. You can start from the rows, you can start from the columns as you wish. So penalty P1, I'm starting from the columns. So what is penalty in this case? Penalty hoti hai the difference between the lowest cost cell and the next lowest. So 120 छोटा है और next छोटा 160 है, so the difference would be 40 in this case. So that is the penalty. सबसे छोटा in the second row is 130 and then it is 90, so the difference would be 60. Here the least element is 80 and this is 140, so the difference would be again 60. Now column wise I would calculate the penalties P2. So this is 140 and 60, सबसे छोटा, and next 20. So this is 130 and 190, so this is 60, this is 80, this is 120, so the difference is 40. So छोटा और उसके next वाला छोटा, उसे immediately बड़ा. सो दिस इज़ हाउ यू कैलकुलेट. अब पेनाल्टीज़ में से सबसे बड़ी पेनाल्टी देखनी है. अब बड़ी पेनाल्टी तो 3 जगह है, ये 60 है, ये 60 है, ये 60 है. तो इस टाई को ब्रेक करने के लिए क्या करते हैं हम देखते हैं कि 60 के अंदर जाके सबसे छोटा कॉस्ट सेल क्या है, क्योंकि ट्रांसपोर्टेशन में हमारा ऑब्जेक्टिव होता है टू मिनिमाइज द कॉस्ट. तो हम देखेंगे कि सबसे छोटा कॉस्ट सेल कौन सा है, हम उसको एलोकेशन करना चाहते हैं इन ऑर्डर टू मिनिमाइज द ट्रांसपोर्टेशन कॉस्ट. तो मैं क्या करूँगी, 60 के अंदर यहाँ पे 130 है, यहाँ पे 140 है, ये 60 के अंदर 80 है एंड इधर सबसे छोटा 130 ही है. सो आई मेक दिस एलोकेशन टू दिस 80 क्योंकि ये सबसे छोटा कॉस्ट है अमंग द 60s. तो इसको मैं एलोकेशन कैसे करूँगी, इधर से 17 है डिमांड, इधर से सप्लाई 12 है. सो आई हैव टू मेक द मिनिमम वन एज द एलोकेशन. मैं मिनिमम छोटे वाले की एलोकेशन कर देती हूँ, ये एग्जॉस्ट हो जाता है, यहाँ पे 5 रह जाता है. सो एज अ रिजल्ट ऑफ दिस पेनाल्टी गेट्स एग्जॉस्टेड, दिस रो गेट्स इट्स एलोकेशन एंड दिस इज आउट ऑफ the calculation. Now row wise calculating the penalty again, it is P3. So 120 and 60 it remains 40, and here the difference 130 and 190 it remains 60 only. So penalty P4 now to be calculated, 120 and 160 and 220, the difference is 60. Here the difference is 60, here the difference is 70. So the highest penalty now is 70. So I would consider this. And इसमें छोटी allocation कौन सी हो सकती है, 120 को. So यहाँ से demand है 5 और supply है 14. So I'll make a 5 allocation. ये exhaust हो गया. यहाँ पे क्या बच गया आपका, 9 बच गया. So as a result this column also gets exhausted. Now I'll again calculate the penalty P5. So the difference here is 30, the difference here is 90, and P6, the difference here is again 60, the difference here again is 60. So 90 is the highest penalty, so I would make an allocation. I'll go inside and I'll see 130. So the allocation that can be made, 15 from this side and 16 from this side, so I'll make an allocation of 15. This gets exhausted, 1 is left over here. So as a result this column also gets exhausted, and Now simply I'm left with 9 and 1 here and 10 here, so I'll make an allocation 9 9, whatever is left. So 9 and 9 corresponding, this is 0, this is 1, and 1 is left corresponding to 220. So 1 from this side and 1 from this side. This is the Vogel's approximation method of making allocations in case of initial basic feasible solution. So now I'll calculate the cost. 160 into 90 plus 220 into 1 plus 130 into 15 plus 120 into 5 plus 80 into 12. So the cost comes to be rupees 5170. So this is how you perform the Vogel's approximation method, and when nothing is mentioned, you have to perform the Vogel's approximation method, because this gives you the cost which is nearest to the optimal cost. So always use Vogel's approximation method when nothing is mentioned. Thanks for watching.